Okay, so we want to look at matrix multiplication today. We want to talk about how it works, the two different ways that we want to think about it, not the two different ways we want to think about it, the two different ways we can compute matrix multiplication, and the primary way we want to think about matrix multiplication. So there are two ways to compute matrix multiplication. Two ways. There are two ways that we can compute AB, the product of these two matrices. First is to make linear combinations of the columns of A using the entries in the columns of B as weights. So thinking about AB, so one is to think AB is the matrix A times the matrix B1, B2, and the columns of the product AB will be the product of the matrix A and the columns of B. So the first entry will be A times B1, and the second column will be A times B2. It's really important that we don't say we distribute A. There's no operation between B1 and B2. We are not distributing A. That's not what the distributive property is about. The distributive property is a relationship between multiple operations. And that's not what's going on here. I don't care what it looks like. That's the reason that you do things like natural log of x plus y is equal to natural log of x plus natural log of y, because you learned the distributive property as some visual thing. But that's not what the parentheses are telling us in that case. But that's beside the point. So if, for example, we want to multiply A times B, we want 2, 0, negative 1, and 1, negative 4, negative 3. If we want to multiply this by 3, negative 1, and 5, 4, the first column of the product will be a linear combination of the columns of A using the entries in B1 as weights. So the first column of the product will be 3 times 2, 0, negative 1, minus 1 times 1, negative 4, negative 3. And then the second column will be the combination of the columns of A using the second column of B as weights. So 5 times 2, 0, negative 1, plus 4 times 1, negative 4, negative 3. So this is all, oops, I've already dropped off the bottom of the page because this is a lot to write. So it's going to be 3 times 2 minus 1 times 1. So 6 minus 1 is 5. 3 times 0 minus 1 times minus 4. So 0 plus 4. And then 3 times negative 1 minus 1 times negative 3. So negative 3 plus 3 is 0, assuming that I'm calculating correctly, which is not a good assumption to make. And then the second column will be 5 times 2 plus 4 times 1. So 10 and 4 is 14. And then 5 times 0 plus 4 times negative 4, so negative 16. And 5 times negative 1 plus 4 times negative 3, so negative 5 minus 12, negative 17. So there's the product AB. I've got a linear combination of the columns of A here. So this column is A times B1. And this column is A times B2. And it's a linear combination of the columns of A using the entries in the corresponding column of B as weights. That's one way to compute AB. This is the linear combinations way of computing AB. This is how we want to think about matrix multiplication. This expands on the way when we learn to multiply a matrix by a vector, and this is how we want to think about it. The other way to compute AB is to make a dot product of the rows of A and the columns of B. So the other way we can think about it is to make a dot product of the row of A and the column of B. I haven't previously defined what a dot product is, but if I have a vector, let's say x1, x2, x3, dot y1, y2, y3, we just make products of the corresponding entries and add them. So one thing to note about dot products that we should note about dot products is that when we're finding a dot product, we multiply a vector multiplied by another vector, and we get a scalar. So sometimes this is referred to as a scalar product, which would be different than like scalar multiplication. A lot of things we have to sort out when we're coming up with the vocabulary for all this stuff. So the other way to compute AB is to find the dot product of the row of A and the column of B. First row of A, first column of B. That's the first row, first column entry in the product. So let's do this multiplication with dot products. So if I want to multiply 2, 0, negative 1, and 1, negative 4, negative 3, by 3, negative 1, and 5, 4. So the first row, first column entry in the product will be a dot product of the first row of A times and the first column of B. So the first row of A and the first column of B. So I'm going to go 2 times 3 plus 1 times negative 1. So 2 times 3 is 6, plus 1 times negative 1 is negative 1, so that's 5. So that's the first row, first column. First row of A, first column of B. So the first row, first column of the product AB is the dot product of the first row of A and the first column of B. Writing it out in words is somewhat tedious, but thinking about it is pretty straightforward. Next, we'll go the first column of A by the second column of B. So that would be 2 times 5 plus 1 times 4. So that'll be 2 times 5 plus 1 times 4. 2 times 5 plus 1 times 4. 10 plus 4 would be 14. So that'll be the first row, second column of the product. So this is that first calculation here. We have the first row of A dot second column of B. Any questions? So we just do row column multiplication. So 0, negative 4 times 3, negative 1. So 0 times 3 minus 4 times negative 1 is 4. 0 times 5 minus 4 times 4 is negative 16. Negative 1 times 3 minus 3 times negative 1 is 0. Negative 1 times 5 minus 3 times 4 is negative 17. So we get the same thing we had before, which has to happen. If you do a problem 2 different ways and get 2 different answers, at least one of those answers is not right. So we haven't formally introduced the dot product, but that's what we're doing here. We're doing a dot product rows of A dot columns of B. Any questions? Note that for a product to be defined, the number of columns of A has to equal the number of rows of B. So AB, oops, that's my symbol for stopping the video, which we have not done. AB is defined when the number of columns of A is equal to the number of rows of B. So AB is only defined when the number of columns of A is equal to the number of rows of B. So in the matrices we have here, if I try to switch the order, so if I just wrote these in the other order, 3, -1, 5, 4, times 2, 0, -1, 1, -4, -3, this product is not defined. So this product is not defined. When in math we say something is undefined, that doesn't mean we haven't got around to defining it yet. That means it cannot be defined. Like division by 0 is not undefined because we just haven't sorted it out yet. Division by 0 cannot be defined in a way that makes any kind of sense. You can obviously make up any kind of rules that you want, but they won't make sense with the rest of it. Eventually it's going to fall apart. You can be like, oh, if we divide by 0, we just get infinity. Except for the times that we get negative infinity, and except for the times that we get a constant, and except for the times that we get 0. So if it's not always going to be one thing, we can't say what it is. Any questions? So that's the deal with matrix multiplication. Let's pause the video now and so we can take a look at homework from section 2.1. So let's pause the video now.